So here we are doing long division of polynomials. So in the last lecture we looked at the idea of proper fractions, improper fractions, and long division of just ordinary numbers. Although a very, very simple case. Here we're going to do long division of polynomials. So if we have a look at the notes, you'll see an example under example 1. And I'm going to copy this in here. You can see it there. Now, this is a top-heavy fraction or an improper fraction, and the reason is the order of the top line is higher than the order of the bottom line. So unless you've got a special case, the easiest way to integrate this is to reduce it to a proper fraction. So just like we did last time with our long division, we turned 7/3 into 2 1/3. We got the kind of division result here and then the remainder in fraction here. We can go back here, we can do this as a long division. So I'm going to work through this as a long division. Now, just like the last time, you put the denominator outside the division sign, 2x plus 5. Then you put your, oops, scribbly. Then you put your top line numerator inside the division. So it's x cubed plus 4x squared plus 7x minus 1. Now remember in the last example we did, we said how many times does the number outside the division go into the number inside the division. So if we have a look at that, the question was how many times does 3 go into 7? We're going to ask that question again, but this time we're only interested in this first term. So how many times does x squared go into x cubed? And the answer is x, because x squared times x is x cubed. So we now, I'll get rid of those discs because they're going to make a bit of those loops, they're going to make a bit of a mess. So the answer is x. So I put that immediately above the x column here. Okay, x goes in there. And then what we do is we say, right, multiply all of this thing outside the denominator by this x. So x squared times x is x cubed. 2x times x is 2x squared. And 5 times x is 5x. And then we subtract. So x cubed times x cubed is 0. That's what we were looking for. Get rid of this first term. 4x squared minus 2x squared is 2x squared. Sorry, I missed out the x there. 7x minus 5x is 2x. And we can drag this down, just write that minus 1 at the end. And now we repeat the process, except now we ask how many times does this go into this? So how many times does x squared go into 2x squared? The answer is 2. So we write plus 2 there, and then we multiply this by the 2. So x squared times 2 is 2x squared. 2x times 2 is 4x. And 5 times 2 is 10. Underline and subtract now. 2x squared minus 2x squared is 0, so that disappears. That was what we were looking for. 2x minus 4x is negative 2x. And minus 1 minus 10 is minus 11. So that's good. Now we ask the question, how many times does this go into this? And the answer is, well, it doesn't. Because this has got a higher order. This is an x squared thing than this, which has just got an order of 1. It's the highest order term is just an x term. So at that point, we stop. Stop, exclamation mark. And then we can rewrite this. So what we do is we have x plus 2. In fact, I'm going to do it in color, x plus 2 there, plus this, the remainder, minus 2x minus 11, divided by, and we'll pick a different color, pick red, this, the original denominator, x squared plus 2x plus 5. Now you can see this follows the same pattern that we had in the long division before. So if I go back a page, look at this, you can see when we did the 3 into 7, we got 2 plus 1 over 3. 2 and 1/3, 2 plus 1 over 3. Go back to this one, we've got that plus that over that. So it's the same pattern. Now we can tidy this up a wee bit more, because that's it basically done. We've got x plus 2 plus, we can take the minus out as a common factor here. Okay, and now we need to put the minus sign in front. So that's x plus 2 minus 2x plus 11 over x squared plus 2x plus 5. Okay, and that's it done. So if we have a look at the notes, you can see here our problem has, now look at this here, that x, that's in the wrong place there. That should be over here. That's a typographic error in the notes. But you can see that actually they go down and we get down to the same result. So in the next one we'll have a look at exercise 2, example 2.